Assalamualaikum and hi students. So this is a lecture video for BEKG 2443 Engineering Mathematics 2. So to begin with, this first video will be about the first chapter, which is function of several variables. So basically the first two LOs will be covered in this first video. For the introduction, before this, you know what is a function with a single variable. So for example, you have fx equal to 2x squared minus 4x plus 2 plus exponent minus x. Okay, so this is example for a function with single variable, a single variable function. Or you might have ft equal to 2 cos 2 pi t minus 3 sin pi t plus 3 exponent minus 3t. So these two example is for functions with single variable. Now we will look at, in this chapter we will look at fxy. This is function with two variables, or you might have f, x, y, z. This is for function with three variables. Subtopic 1.1, function of two or more variables. Okay, first we consider the functions of two variables. Okay, a rule that assigns a real number fxy, we have two variables here, x and variable y, to each ordered pair of real numbers xy in the domain of the function. For instance, okay, for example, an area of a rectangular. Okay, fxy is equal to xy, where x is the length and y is the width. So that's why we have a function with two variables. We have variable for length and width. Okay, let's see the definition 1.1. Suppose D is a set of ordered pairs of real numbers x and y. A function with two variables x and y denotes as z equal to fxy. The set D is the function's domain. Okay, so this is the definition for domain. The set of z's values that associate with the numbers in these functions is the range. Okay, so basically domain is the value of x that makes this function defined. Okay, so there will be three restriction for three cases for the domain, to determine the domain. And then for the range is the z's value after you substitute all the possible domains. Now let's see two examples. Okay, so the first example is for fxy, function of two variables x and y. You have x squared plus square root of y. Find f negative 2, 9, f half 0, the domains and the range of this function f. Okay, so what does it mean by finding f minus 2, 9? Okay, so this means you substitute x equal to negative 2 and y equal to 9 into fxy here. So for f negative 2, 9, this is equal to, you have negative 2 square plus square root of 9. So use your calculator. You have negative 2 square, you have positive 4 plus square root of 3 is square root of 9 is 3. So for this, you have 7. Right? Next, move to f half 0. For f half 0, substitute x with half square plus square root of 0. So square of half is equal to 1 over 4, and square root of 0 is equal to 0. So for this one, you have 1 over 4. Right? Okay, next, for the domain. Okay, so for the domain, like what I said before, the domain is the value for x and y. Okay, the domain is referred to our variable x and y. So for this case, we have x squared plus square root of y. For x squared, we don't have any restriction. But for square root y, okay, for square root y, you see, for example, if you have square root of 4, square root of 4 is equal to 2. Okay, what if I have to find square root of 0? Square root of 0 is equal to 0. But if you find the square root of -4, this is equal to a complex number. This will be 2i. Okay, so for a complex number, it makes the function undefined. So the first restriction is if you have a square root of a, the a must not equal to negative number, but it can be a positive number. So this is the restriction. Okay, so writing the domain d for domain, df, f is our function. If you have this g, f, gxy, so this will be dg. So for df is equal to, okay, so we will consider the value of xy, right? So write x and y. Okay, so x, y will be any real number r, but you need to include the restriction. Okay, for this one we have the restriction for y. So our y here should be always positive. No restriction for x, so we just put y, restriction for y. Okay, so this is the domain. And then solve for the range of f. Since for the range we consider the value of f, x, y. When you substitute all the possible value of x, y, okay, what happened to the f, x, y here? Okay, when you substitute 0, 1, 2, 3, negative 2, negative 3 plus with this one. Okay, so here, since this is always positive, so, right, this is always positive because you have -2 square, you will have 4 here. And then this one, since you just consider y positive number, so this will give you positive value. So since here you have positive value plus positive value, so your range will always be a positive number. So this is how you write the range. Okay, for the second example, you have this fxy, these two variable function x and y equal to x ln y plus x square. Find f11 when you substitute x equal to 1 and y equal to 1, f2 exponent, domain, and then you need to find the domain and the range for f. Okay, for this one, let's start with finding f11. So f11, substitute your x and y, you will have here 1 ln 1 plus 1 square. So 1 ln 1, when you use substitution, when you use calculator, you have this equal to 0. Plus 1 square is equal to 1, so this is 1. Okay, next, f2 exponent. Exponent here means exponent 1. Okay, so you have here 2 ln exponent 1 plus 2 square. So 2x ln with exponent 1 is equal to 1. Okay, ln multiplied by ln exponent is equal to 1. So you have 1 multiplied by 2, you have 2 here, plus 4. So this will give you 6. Right? Okay, next for the domain f. Okay, we want to find what is the restriction, what is the value for x and y. So x and y, first you start with x and y, can be any real number, then comma, then put your restriction. Okay, there is no restriction for x square. You can have any number of x, any value for x, but then there is a restriction for ln y. Okay, so when you try to find ln 1, so ln 1, when you use calculator, you find this is equal to 0. So there is a value. But if you try to find ln 0 using the calculator, okay, let's say you have ln 0, you got math error. So this means you have undefined value for ln 0. Okay. Next, what if you have negative value, ln -1? Okay, let's see ln -1, also a math error. So you have undefined value. So what can you conclude here? So for ln A, there is a restriction for ln A where A should be always greater than 0. It cannot be equal to 0 or less than 0. Okay, so another restriction here you need to put is y should be always more than 0. More than 0 doesn't include the 0. Okay, positive value. Okay, next, last, we have to find the range. For the range, okay, to find what is the value for fxy. So for this one, when you substitute ln y, x ln y, you have any real number. Okay, and then this one is positive number. This one you can have a negative value here, and then for this one you can have positive value. Okay, so for fx1, we will have any real number. All numbers can be our range. Okay, move to graphing of two variables. For two variable functions, graph gives a surface where its domains is in xy plane. Okay, so since this is two variable functions, so we have xy planes. The function value z equal to fxy is the distance from xy plane to z axis. Okay, so imagine the 3D graph. Okay, the two steps in sketching the graph of fxy. First step is to draw the level curve in the domain xy where f has a constant value. Then the last step is to sketch the surface z equal to fxy in space. Okay, so before we move to the example, let's see what is the definition of level curve, contour curve, and surface. Okay, for definition 1.2, the set of points in the plane z equal to fxy equal to k, where k are constants, is called the level curve. So basically, k is our level curve. The set of level curve from here, the set of level curve is called contour curve. And last, the surface z equal to fxy is the set of all points x, y, z. fxy is our z, okay, in space. Now, let's see one example out of two examples we have here. So the first example, a function z equal to fxy is defined as z equal to fxy equal to 4 minus x square minus y square with domain, you can see domain here, x square plus y square less or equal to 4. Show the level curve at k equal to 0, k equal to 1, k equal to 2, and k equal to 3. Then sketch the graph of z equal to fxy. So first you need to show the level curve. Okay, so before this, we know that the level curve is equal to z equal to fxy equal to k. So k is our level curve. So k here, substitute the value. So this is z fxy. So it's equal to 4 minus x square minus y square equal to k. Okay, So this can be written as x square plus y square equal to 4 minus k. And then substitute the value of k. So since we have k equal to 0, k equal to 1, k equal to 2, and k equal to 3. So let's see the level curve of this k. So when you substitute k equal to 0 here, you have x square plus y square equal to 4. This is x square plus y square equal to 3. 4 minus 1. Next, x square plus y square equal to 2. And last, when k equal to 3, we have x square plus y square equal to 1. So what you can conclude here when you have x square plus y square equal to this r? So basically, this is a general formula for you have x square plus y square equal to r square. This is general formula for a circle with radius r. Okay, so for this one you have radius 2, radius square root of 3, radius square root of 2, and radius 1. Okay, so let's sketch the level curve. Okay, for the level curve, you have the xy plane. So let's say this is your x and this is your y. Okay, for x square plus y square equal to 4, so you have a circle with radius 2. So let's say you have here, this is a circle with radius 2. This is minus 2, this is 2, this is minus 2. So basically, this is your level curve at k equal to 0. Okay, k equal to 0. Okay, next for k equal to 1, your x square plus y square, your radius is at square root 3. So sketching, just sketching, okay. So this is square root 3. And then you have at square root of 2 here, let's say, and this is square root of 1, which is equal to 1. So this is level curve for k equal to 1, this one for k equal to 2, and the innerst one is for k equal to 3. Okay, so this is your contour curve on xy plane. Okay. Okay, so you just show the level curve at k equal to 0, k equal to 1, k equal to 2, and k equal to 3. Next, what you need to do is to sketch the graph of z equal to fxy. Okay, to sketch the graph of z equal to fxy, you need another two graph, okay, which is on zy plane and another one in zx plane. So then you can combine these three plane, xy plane, zy plane, and zx plane. So before this, okay, so your z equal to fxy equal to 4 minus x square minus y square. Okay, for zy plane, you need to consider when x equal to 0. So just substitute x equal to 0 here. So you have 4 minus y square equal to z. Okay, and then this one is for zx plane. So when y equal to 0, your z is equal to 4 minus x square. So you have z equal to 4 minus y square and z equal to 4 minus x square. So basically, this is a parabola on the zy plane, while this one is the parabola on the zx plane. Okay, so for this one, z equal to 4 minus y square, so it's a set face. Okay, and then you have intersection at 4. So this is 4, this is 4. So basically this is the curve for z equal to 4 minus y square. And for z x plane, you have this 4 intersection at 4. So this is z 4 minus x square. So for sketching the ZFXY, so we have the 3D. Okay, you have this is your x-axis, your z-axis, and your y-axis. Okay, so first draw the ZY plane. Okay, so for ZY plane, you have this one, right? So you have this is 4 here, you have another 4 here. And then for ZX plane, you have this one. I'm sorry, this curve. Sorry, it's not perfect. Sorry. Okay, so this is 4. Okay, and then consider the XY plane. Okay, so for XY plane, you have this one. Okay, this one, you have how many? You have how many level curve? Okay, 4, is it? Okay. Okay, so basically this is for z equal to 3, z equal to 2, and z equal to 1 plus z equal to 0. So this graph is the surface of z equal to fxy on XYZ plane. Okay. For the second example, we have to sketch the contour curve. Okay, the contour curve and the surface at k equal to 0, k equal to 1, k equal to 2. Okay, for the function fxy equal to square root of x square plus y square. Okay. So for the contour curve, okay, z is equal to fxy equal to k. Then substitute this, you have x square plus y square equal to k. Okay, so this is x square plus y square equal to k square when you move the square root to the right hand side. Okay, so you have this the formula for circle with radius k. So you have k equal to 0, k equal to 1, and k equal to 2. For k equal to 0, you have x square plus y square equal to 0, x square plus y square equal to 1 for k equal to 1, and then we have x square equal to plus y square equal to 4. 2 square is 4. So we have these 3 circles. Okay, so you can sketch your y-x plane here for the contour curve. Okay, for the level curve. So for y-x, we have first circle at radius 0 here, and then second you have at radius 1, you have 1 here, and then you have a circle at radius 2 here. So label this is k for k equal to 2, while this one is for k equal to 1. So what is this? What is this? This is the contour curve on xy plane. Okay, so move to the surface. To find the surface, you need to have these two planes, z, y, and z, x plane. Okay, for this one, okay, we have z equal to square root x square plus y square. Okay, consider when x equal to 0 for this ZY plane. So when x equal to 0, the z's become square root of y square. Okay, so this is 0. So square root of y square is y. So you have z equal to y here. Okay, so graph for z equal to y is this one. This is z equal to y. Then for zx plane and y equal to 0, z becomes square root of x square. And this is z equal to x. The graph, the line for z equal to x is this. Okay, so combining these three plane, xy plane, zxy plane, and zx plane. Okay, you will come out with these 3D. You have here x, y, and z. Okay, for zx plane you have this line, zxy plane you have this line, and then for xy plane you have these two circles. Okay, so you have this circle and this one on the xy plane. So basically this is for z equal to 2 and this is for z equal to 1. For z equal to 0, you have this circle at radius 0. For this one, this is the surface on x, y, z plane. That's it for second example. Now we will look at functions of three variables. Okay, a rule that assigns a real number fx, y, z to each ordered triple of real numbers x, y, and z. So now you have extra variable z in the domain of the function. For instance, this is a volume of a cuboid. Fx, y, z equal to x, y, z. X is length, y is the width, and z is the height. Okay, so this is an example for three variable functions. Okay, so for definition 1.3, we have the definition of a function with three variables. Okay, where it is a rule that maps the dependent variables x, y, z to the independent variables w. Okay, the domain is the set of numbers that is mapped to the independent variables, and the range consists of the output values for w. So basically, it's just the same as definition 1.2, but with extra variable z. I have two examples here. Given fx, y, z equal to y, z over x plus 2, find f0, 1, 1, 0, 1, 1, f negative 1, 1, 3, domain and range of this function. Okay, so f0, 1, 1 means that your x value is 0, your y value is 1, and your z value is equal to 1. You need to substitute these three values into this fx, y, z. Okay, so f0, 1, 1 will be y is 1, z is 1 divided by x0 plus 2. So this is equal to 1 over 2. Next, for f negative 1, 1, 3, we will have 1 multiplied by 3 divided by minus 1 plus 2. And this is equal to 3 over 1, which is equal to 3. Okay, now the best part of this, we need to find the domain. Okay, that I said before, for the domain, we consider the value for the independent variable x, y, and z. Okay, so for x, y, and z can be any real number, and then you need to put the restriction here. Okay, so there is a restriction for fraction. Okay, for fraction to be defined, okay, y z over x plus 2. So basically, the denominator x plus 2 shouldn't be equal to 0. Never. Means that x cannot be equal to minus 2. Why? Because if you have 1 over 2, this is equal to 0.5. If you have 1 over minus 4, this is minus 0.25. But if you have 1 over 0, this is totally undefined. That's why. Okay. So for this fraction, the restriction is when you have b over a, the a shouldn't be equal to 0. Okay. So for this one, you need to put the restriction here. Why? Z can be any real number. But x plus 2 cannot be equal to 0. So x cannot be equal to negative 2. Okay. So this is your domain. And last one, you need to find the range. So range is when you consider the dependent variable f, x, y, z. Okay. So what happened to f, x, y, z value when you substitute all the domains here in this f, x, y, z? Okay. So f, x, y, z can be any number. You can put any number here. You can put any number here except for negative 2. So the total of this one, this function, is any real number. It can be any real number. Okay? The second example, for f, x, y, z equal to z squared plus sine x, y, find f1 pi over 2, negative 2, f0, 1, 2, domain and the range. Again, okay? So for this one, you need to substitute x equal to 1, y equal to pi over 2, and z equal to minus 2. So minus 2 square plus sine 1 pi over 2. Okay? Okay, remember, whenever you want to find this value for sine, involve the pi or pi over 2 or pi over 4. Make sure your modes in radian. Okay, change your mode. So see, okay, this one. Okay, and then press 2 for radian. Okay, if you do this using degree, you will get the wrong answer. Okay, right, using the radian, you will get negative 2 square plus sine pi over 2 is equal to 5. But if you do this using the degree mode, the answer you get is 4.0274, which is the wrong answer. So make sure if you want to find the value for sine, cos or tan, make sure your calculator mode is in radian. Okay, so this is 5. Then for f0, 1, 2, this is equal to 2 square plus sine 0 multiplied by 1. Okay, sine 0 equal to 0. 2 square is 4. So the answer is 4. And then for the domain f. Okay, for x, y, and z. Okay, so x, y, z can be any real number. Why? Because there is no restriction for z square and there is no restriction for sine x, y. So remember that the restriction that you have only 3 restrictions. The first restriction is for lone. Second one is for the fraction, and the third one is for the square roots. You just only have 3 restrictions for domain. Okay, no restriction for sine, cos. Okay, and then for the range f. So for the range, we look for the value for f, x, y, and z. Okay, so for this one, what is the value for f, x, y, and z when you substitute the domain? Okay, for this one, you need to consider the graph for sine. Okay, the graph for sine is this one. Since you have sine 0 equal to 0, you have this one, right? So this is 1, this is minus 1. So the range here will always in between -1 to 1. Okay, the range for sine, this is for sine t. Sine t or sine any value x, y, it can be sine x, y. Okay, so for sine x, y, here the value is from -1 to 1, but you have positive value here, z square. So z square plus with this range, you will have more than -1. It cannot be less than -1, the range, the value for fx, yz. Okay, and for the last subtopic for this 1.1, okay, level surface of three variables functions. In space, the points where a function of three variables has a constant value fx, yz equal to k, make a surface in the function's domain. Okay, definition 1.4, definition for level surface of W is the set of points x, y, z where W equal to fx, yz equal to k, and k is a constant value. Okay, if the values are set as k1, k2, and k3, three level surfaces will be obtained and presented by S1, S2, and S3. Okay, each surface is the same shape of each other. Okay, we see the repeated shape in the graph. Okay, we will see this in our next example. Okay, the first example, describe the level surfaces of fx, yz equal to x square plus y square plus z square equal to, x square plus y square plus z square for k equal to 0, 4, and 9. Okay, so again, W is equal to f x, y, z equal to k. So we have here x square plus y square plus z square equal to k. Okay, so for k equal to 0, we have x square plus y square plus z square equal to 0. And then we have for k equal to k equal to 4, we have x square plus y square plus z square equal to 4. And for k equal to 9, this is x square plus y square plus z square equal to 9. And this is basically the general formula for when you have x square plus y square plus z square equal to r square. It is a general formula for sphere with radius r. Okay, so how to sketch the level surface? Okay, so you have in 3D, you have this z here, you have y here, and you have x here. Okay, so sphere, what is sphere with 4? So you have this one. Okay, it is a 3D, so you have here. So basically this is the K1. For the K1 is equal to, for K equal to 0, we don't have any for K equal to 0. So this is for K equal to 4. And then with K equal to 9, we have this one. Okay, this is 3D. So you have this one. So this is for K9. For K9, you have x square plus y square plus z square equal to 9. And for K4, you have x square plus y square plus z square equal to 4. So this is the level surface of of f x, y, z equal to x square plus y square plus z square equal to k. Okay, so if we see here, it says that each surface is the same shape of each other. So that's why you have these two, the same shape of sphere here. Okay, so So this is our last example for this video. Okay, given a function w equal to fx, yz equal to z equal minus square root of x square plus y square. Sketch the level surface of f for k equal to minus 1, 0 and 1. So again, this is equal to k. Substitute into our case, our example, we have z minus x square plus y square equal to k. So the z becomes k plus x square plus y square. Then substitute the k value. K equal to minus 1, k equal to 0 and k equal to 1. So this is z equal to x squared plus y square minus 1. And this is z equal to x square plus y square. And last but not least, we have z equal to x square plus y square plus 1. Okay. So we have these three. This is, when we write this in general form, we have z equal to x square plus y square plus a. So what does it mean? Okay, this means you have the cones at vertices 0, 0, a. So meaning that this is the cone at vertices minus 1 at 0 and vertices at 0, 0, 1. Okay, how to sketch this? So again, we have this z, y and x. Okay, so for the first one here, you have a cone at vertices minus 1. Since our a here is minus 1 for k equal to minus 1. So you have here the cone. Okay, so let's say we extend this. So this is minus 1. And then for this one, a is equal to 0. So this is your second cone. And for the last cone, let's say this is 1 here. So this is your third cone. Okay, you can sketch it better than me, I think. This is just too, I don't know. So this is z equal to x square plus y square plus 1. So this is your 1. Okay, so this is z equal to x square plus y square. Okay, plus 0 here. And this one is for z equal to x square plus y square minus 1. And this is the level surfaces on x, y, z plane. Okay, so that's all for this video. We continue with limits and continuity in our next video. Thank you.